So now that we know how to set up ice tables, we're going to practice solving an ice table by using the quadratic formula. So I have rewritten my equation right here, and the first thing we need to do is set up our ice table. So we're told that we are starting off with 0.1 molar of both CO2 gas and H2 gas. So that's what we're going to fill in our initial. And because we're not told anything about CO gas and H2O gas, we're going to assume that we have none to begin with. So now for our change, since none of our reactants or products in our equation have any coefficients, we don't need to have minus 2x or anything like that. We just can do minus x's for our reactants and plus x's since we're forming these products. And so that gives us for our equilibrium 0.1 molar minus x, and the same here for H2 gas. And then just x's for our CO gas and H2O gas. And so in order to solve for these x's, we need to do our concentration of products over our concentration of reactants and set that equal to our Kc value. So that gives us 0.64 is equal to x squared over 0.1 molar minus x times 0.1 molar minus x. And so our first step in simplifying this is foiling our denominator here. And this is just basic algebra. And FOIL stands for first, outer, inner, last. And so when we FOIL our denominator, we get 0.01 minus 0.1x minus 0.1x plus x squared. So after combining these like terms, this is the denominator we get, and we plug that back into our original fraction. The next step in simplifying this fraction is by multiplying both sides by this denominator. And when we multiply both sides, we get 0.64 x squared minus 0.128x plus 0.0064 is equal to x squared. Now, in order to plug this equation into the quadratic formula, we need to have the equation in its quadratic form. And so we can do this by subtracting both sides by all of these values here on the left side, and to get all of our variables on one side and have it equal to 0. And so when we do that, we get 0.36 x squared plus 0.128x minus 0.0064 is equal to 0. And so these are the values that we will be plugging into the quadratic formula. This is the A value, this is B, and that's our C value. So now we are ready to plug our values into the quadratic formula. Remember that this formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the first step I'm going to do is just plug all of my values in, not simplify or anything, just plug them in. So that gives you x equals negative 0.128 plus or minus the square root of 0.128 squared minus 4 times 0.36 times negative 0.0064. And all of that is over 2 times 0.36. So my next step in simplifying this and solving for x is just to multiply anything that can be multiplied, and then I'm going to subtract my values underneath my radical. And that gives me x is equal to negative 0.128 plus or minus the square root of 0.0256 over 0.72. My next step is taking the square root of 0.0256. And so that will give me x is equal to negative 0.128 plus or minus 0.16 all over 0.72. When you use a quadratic formula, you get two answers because of this plus or minus here. So that means that you have to solve this equation twice, one time adding the two values in your numerator and one time subtracting them. So we're going to do it both ways and find two values, and then from there we'll decide which value we're going to accept. So when we add the two values, it'll look like x equals negative 0.128 plus 0.16 over 0.72. And that will give us an x value of 0.044. When we subtract them, it will look like x equals negative 0.128 minus 0.16 over 0.72. And that gives us an x value of negative 0.4. So these are the two values that we are determining our answer from. In order to decide which one we want to use, we need to plug these back into our ICE table up here. You cannot have any negative concentrations, so when we see that x by itself here would be a negative 0.4 concentration, we know that we can't accept this answer. And this one is our correct answer. And so now let's look back at what our question wants. We want the final concentration of CO2 gas at equilibrium, so we need to plug our accepted answer back into this equilibrium concentration. So that would be 0.100 molar minus our x value, which is 0.044. And that will give you a final concentration for CO2 gas of 0.056 molar.